Dear Chairman, this presentation shows part of the results that have been collected during the much wider research at University in Belgrade regarding thermal comfort condition in university buildings. The presentation consists of introduction, standards regarding thermal comfort, methodology of research, classroom description, result and discussion, and finally conclusions. It is widely known that comfort, by definition, is that condition of mind that expresses satisfaction with the environment. So during the indoor environmental design, it is very important to assure the comfort and health condition in buildings. But that is not always possible in existing buildings, especially in naturally ventilated ones, which have a problem to meet the criteria prescribed by the international standards regarding thermal comfort. These optimal thermal comfort parameters are of high importance in buildings because the inadequate thermal environmental conditions leads to the various health problems. Besides this, a lot of studies showed that poor indoor environmental quality cause student productivity loss. And some studies showed that learning performances could decrease 10 to 14% when effective temperature increases from 24 to 27 or 29 degrees Celsius. Other studies also showed that productivity loss is lower than 5% when indoor air temperatures are in between 22 and 24 degrees Celsius. But productivity loss goes up to 12% when indoor temperature goes up to 26 degrees Celsius. Thermal comfort requirements are prescribed in a lot of standards worldwide. One of the most important is 7730, which determines the methods for predicting the thermal sensations and degree of discomfort of people exposed to moderate thermal environments. According to this standard, it is possible to calculate PMV and PPD indexes, which represents the thermal balance of the whole body. Also, it is possible to calculate the local thermal discomfort criteria, which are prescribed and given according to 3 categories in these standards, which are shown in Table 1. First part of the table is for PMV and PPD indexes for the whole body, and the other part is for local discomfort, which can be caused by drought, vertical air temperature difference, warm and cold floors, and gradient asymmetry. Also, very important standard is ASHE Standard 55, which also defines the conditions that provide thermal comfort, and the conditions for whole body comfort and local discomfort are also shown in Table 2. And the third important standard is 15251, which defines the criteria for thermal comfort, but also prescribes the methodology for subjective evaluation of occupants in buildings. And the recommended categories are divided according to this standard in 4 categories, which are shown in Table 3. Speaking about the occupant survey on site, it is important to prepare the questionnaires for occupants, which should be prepared according to also European or international standards. One of them is 10551, which recommends the principle of subjective judgment scale construction and also conditions of use. So it is prescribed that judgment scale should have 7 degrees, starting from -3 for cold condition to +3 for hot condition. In the middle of the scale is a neutral thermal comfort environment. According to the main physical parameters such as air temperature, mean radiant temperature, relative airspeed, and humidity, thermal comfort in building can be described. But also very important are personal factors such as clothing and metabolic heat production. The questions about occupants' clothing and activity should be, of course, included in questionnaires during the survey on site. During this research, university classroom at mechanical engineering faculty in Belgrade was observed. It was a naturally ventilated classroom, and research was conducted during 4 weeks of winter semester. The population were predominantly male, aged about 25 years. Students were wearing typically winter clothing, sweater, shirts, trousers, socks, and winter shoes, which corresponds to 1 met according to international standards. During this research, various types of measurements were done, but that is not presented in this presentation. Physical parameters were measured, such as air temperature, radiant temperature, air humidity, air velocity. Also, CO2 concentration in classroom were measured during the period of 4 weeks. According to the measured physical parameters, PMV indexes were calculated according to the prescribed methodology in standard 7730. Also, a new questionnaire was developed according to the international standard 10551. It has 3 parts. First part with a question about physical state of student, then type of the clothing, and the questions about thermal comfort sensation of occupants. Students were asked to evaluate the thermal comfort condition in classroom, but never before minimally 90 minutes spent in classroom. This survey was anonymous in order to provide the objectivity of research, and was performed every day during the 4-week period. The part of questionnaire dedicated to thermal comfort had a typical thermal sensation scale, starting from -3 for cold condition to a +3 for hot environment. The classroom was located in an old building of Faculty of Mechanical Engineering. It was southeast oriented with 1 external wall and 2 windows with radiators above them. And it was about 52 square meters of total heated area with a total number of 30 seating places for students. But it wasn't not occupied fully during 4 weeks. The classroom was divided in 5 sections. First section near the indoor walls, second section near the entrance door, sections near the windows, and section in the middle of the classroom. This division was made in order to have the idea about local thermal discomfort in different parts of the classroom. The measurements were performed every day, and the results were gathered with a step of 5 minutes between the measurements, and were averaged for every day and for every week. The statistical survey was conducted once per day for each day during the 4 weeks period. The students' votes who felt sick were excluded from the final results in order to have the objective results of the survey. According to the measured data, a PMV index was calculated for each student position and averaged, of course, for each week. The results are shown in this table. It's the first part of the table due to the comprehensivity of the results, and a comparison is made between the measured and calculated PMV index and between the thermal sensation votes which were gathered through the statistical survey. White cells are left blank because on this position no one seated during the 4 weeks. This is the second part of the classroom. And the average results for 4 weeks are shown and compared in table 5 for PMV indexes and for thermal sensation votes. It is shown that occupants tend to have about 50% higher thermal sensations comparing to the PMV index that was calculated. But according to students' votes and also according to measurements, the second week was the week with the most favorable thermal conditions. Also, the third week was the worst one. This study showed that the ranking of the most favorable thermal conditions by measurement and also by survey showed the same trend, and the comparison showed that occupants had a 50% higher thermal sensation than it was actually measured. It happened because the population was a healthy young male population affected by high metabolism, and they preferred colder indoor thermal conditions that it was during these 4 weeks. Also, some other studies showed that slightly cool thermal environment is better for learning and working process in buildings. This is very important, especially in project design phase for educational and office buildings, having in mind that learning and working process and together with, of course, occupants' health are influenced by the indoor thermal conditions. Thank you very much.
Thank you very much.